You're supposed to solve each equation or inequality, and you're supposed to round to the nearest 10,000th. That's 4 decimal places. Number 1, since the exponent is a variable, you would want to log both sides, and I would suggest using common logarithm. That means the base is 10. In doing so, this will allow you to take your exponent, x, and move it to be a coefficient. That's the power property. Then to get x by itself, divide both sides by log of 8. Put that in your calculator, making sure to put parentheses around the 10 and the 8. You get about 1.1073. Number 2 is done the same way. Common log both sides. That moves your exponent to be a coefficient. Divide both sides by log of 12. Put it in your calculator, making sure to use parentheses around the 18 and the 12. And you get x is about 1.1638. Number 3 is slightly different. It's an inequality. However, solving it is the same. You just have to check your work at the end. If you log both sides, move your exponent to be a coefficient using the power property. Divide both sides by log of 2.4. Gives you x is less than or equal to 3.4219. In interval notation, which is what you have to use for inequalities, you get negative infinity to 3.4219, including that number. That's why there's a bracket. Sometimes when you have inequalities, you get some strange answers and you don't even know it. So if you take your original inequality and get 0 by itself by subtracting 20 from both sides, you get 2.4 to the x minus 20 is less than or equal to 0. Reading it with the x side first, we're saying that we want negative answers because it has to be less than or equal to 0. So take the solution that we got, 3.4219, pick a test point on a number line to the left and the right of that. Plug that into the original inequality with 0 by itself here. If you put in a 0 in, you're going to get a negative answer. If you put 100 in for x, you're going to get a positive answer. We're looking for negative answers because it says less than or equal to. That just confirms that the answer we had was correct. So less than 3.4219. Number 4, very similar. Log both sides. This enables our exponent to pull out to the front. Since our exponent is more than one term, it must be in parentheses. Divide both sides by log of 1.8. To get x by itself, you get rid of the subtract 5 by adding 5 to both sides. Put that in your calculator, making sure you put parentheses around the 19.8 and the 1.8. You're going to get approximately 10.0795. We don't have to check that answer because it's not an inequality. Number 5, apply log to both sides. Your exponent comes out to the front. Make sure you put it in parentheses, more than one term. And divide both sides by log of 4. Subtract 1 from both sides, trying to get x by itself. And divide both sides by 2. When you're dividing by 2, it's going to put the 2 on the bottom of the fraction. That's why that 2 is at the bottom there, 2 log of 4. 1 divided by 2, of course, is 1/2. Put that in your calculator. You get 0.4815. It's important when you put this in your calculator, since our denominator has a 2 times log of 4, you need to put that in parentheses. Parentheses, 2 log, parentheses, 4, parentheses, parentheses. Number 6, if we log both sides, pulls the exponent out to the front. You divide both sides by log of 3, and divide both sides by 5. Put that in your calculator. You get x is about 0.8088. Once again, when you put this in your calculator, put a parentheses around the entire denominator because there's more than one thing in it. Number 7, it's an inequality. Theoretically, we should have to check our answer on a number line, but since x is already by itself, we don't have to check it. Change a base rule. You get log of 15 over log of 2. Put it in your calculator, and you'll find that your answer goes from negative infinity to 3.9069. Parenthesis here, not a bracket, because it just says less than. Number 8 is the same thing. Change a base rule. Put it in your calculator, and you get that your x's go from 2.90 283 to infinity. Number 9, you don't need logarithms at all. Trying to get x by itself, you have to use logarithms if you have an exponent that's a variable. We don't have that. If we raise both sides to the 3/2, on the left your exponents cancel. On your right, just put it into your calculator and you get 127.2567. Interval notation includes a number, so use a bracket, 1.27.2567 to infinity. Number 10, opposite of an exponent of 0.4 would be the root of 0.4. So you take each side to the 0.4 root. Left side gets you x, the right side put it in your calculator, you get 1552.9394. There's no interval notation because it's an equal sign. Number 11, if you log both sides, that enables us to take our exponents and put them as coefficients. Use the distributive property on your left. And then our goal here is to get our x's on the same side of the equation. I'm going to subtract x log of 2 from both sides to get my x's on the left. I'm going to add 2 log of 3 to both sides to get my terms without x's on the right. Now on the left, I can factor an x out of those terms, which is going to enable me to get x by itself by dividing both sides by 2 log of 3 minus log of 2. Then you got to put that in your calculator. You get about 1.4608. Notice once again, you got to put the 3 in parentheses. You got to put the entire denominator in parentheses. You need the 3 on the bottom, the 2 on the bottom in parentheses. If you didn't get the right answer in your calculator, it's because you're not using your parentheses correctly. Number 12, if you log both sides, it's very similar to number 11. Takes the exponent, puts it in front. Use the distributive property once again. Here, if we simply add 2 log of 4 to both sides, we get our x's on the same side. You can factor an x out on the right. You can factor a 2 out too, but there's no point to it. You just want the x by itself. Divide both sides by that mess on the right. Put that in your calculator using parentheses appropriately. You get 0.2789.